History of probability. Definition of probability. Probability is a branch of mathematics that deals with the likelihood or chance of events occurring. It provides a quantitative measure of uncertainty and is used to analyze and model situations where there is randomness or variability. The foundation of probability theory lies in the study of random experiments, which are processes that lead to uncertain outcomes. Importance of probability. Used to analyze and model situations with random or variability. Fundamental in decision-making under uncertainty. Basic concepts. Sample space, S, set of all possible outcomes in a random experiment. Event, E, subset of the sample space representing particular outcome. Real-world examples, weather forecasting, probability of rain. Medical diagnosis, probability of a disease. French society in the 1650s. Gambling was popular and fashionable, not restricted by law. As the games became more complicated and the stakes became larger, there was a need for mathematical methods for computing chances. Origin of probability theory. History. A well-known gambler, the Chevalier de Mere, consulted Blaise Pascal in Paris about some questions about some games of chance. Question posed by a gambler, Chevalier de Mere, and then discussed by Pascal and Fermat.
There are many versions of this problem, appearing in print as early as 1494 and discussed earlier by Cardano and Tartaglia, among others. The problem of points. Two players of equal skill play a game with an ultimate monetary prize.
The first to win a fixed number of rounds wins everything. How should the stakes be divided if the game is interrupted after several rounds but before either player has won? The classical probability. The correspondence between Pascal and Fermat is the origin of the mathematical study of probability. The method they developed is now called the classical approach to computing probabilities. The method: suppose a game has n equally likely outcomes, of which m outcomes correspond to winning. Problems with the classical method. The classical method requires a game to be broken down into equally likely outcomes. It is not always possible to do this. It is not always clear when possibilities are equally likely. Experience. Another method, known as the frequency method, had also been used for some time. This method consists of repeating a game a large number of times under the same conditions. The probability of winning is then approximately equal to the proportion of wins in the repeats. Presentations are communication tools that can be used as lectures, speeches, reports, demonstrations, and more. Jacob Bernoulli. A member of the prominent Bernoulli family, Jacob made substantial contributions to probability with his work on the law of large numbers. This law describes the convergence of sample averages to the expected value as the number of trials increases. James Bernoulli proved that the frequency method and the classical method are consistent with one another in his book Ars Conjectandi in 1713. Abraham de Moivre. De Moivre, a French mathematician, made important contributions to probability, particularly in the development of the normal distribution and the theorem bearing his name to make the classical method more useful, including the multiplication rule, in his book The Doctoring of Chances in 1718. The book was popular, eventually going through 3 editions. From games to science. Throughout the 18th century, the application of probability moved from games of chance to scientific problems. Mathematical theory of life insurance. Life tables. Biological problems. What is the probability of being born female or male? Applied probability. Pierre-Simon Laplace presented a mathematical theory of probability with an emphasis on scientific applications in his 1812 book Théorie analytique des probabilités. Unfortunately, Laplace only considered the classical method, leaving no indication on how the method was to be applied to general problems. Stagnation. The frustration. After the publication of Laplace's book, the mathematical development of probability stagnated for many years. By 1850, many mathematicians found the classical method to be unrealistic for general use and were attempting to redefine probability in terms of the frequency method. These attempts were never fully accepted and the stagnation continued. Axiomatic development. Andrei Kolmogorov developed the first rigorous approach to probability in his 1933 monograph. He built up probability theory from fundamental axioms in a way comparable with Euclid's treatment of geometry. His work Foundations of the Theory of Probability became cornerstone for modern probability theory. Probability today. Modern research in probability theory is closely related to the mathematical field of measure theory. Modern innovators in the field include Patrick Billingsley, University of Chicago; Yuan Shichao, Columbia; Kai-Lai Chung, Stanford; Samuel Carlin, Stanford; Rolf Dieter Rice, Sheldon Ross, Berkeley; Henry Teicher, Rutgers, and many more. Importance of probability in various fields. Statistics. Probability is fundamental to statistics, guiding methods for data analysis, hypothesis testing, and making predictions based on sample data. Finance. In finance, probability models help assess and manage risk. From pricing options to portfolio management, understanding probabilities is essential for making sound investment decisions. Thank you.